Welcome to the JITX Quickstart tutorial series. This set of videos will take you from zero knowledge of JITX through designing an industrial control and sensing board within a few hours. You'll learn how to get productive in JITX quickly. You'll also learn how to write parametric reusable code that accelerates your design process. And finally, you will use a signal integrity aware autorouter to create dense, efficient layouts that run on fewer layers. Here's a block diagram. 24-volt power and gigabit Ethernet network a chain of microcontrollers that interface with configurable sensors and actuators. This is a great architecture for everything from motor drivers to a field of distributed sensors. First, we're going to get started by installing and creating a new project from scratch. JITX runs on Mac, Linux, and Windows. Go ahead and install VS Code if you don't have it already. There's a link in the description below. Then install the JITX extension. Next, let's create a new project. Open the JITX sidebar. Sign in using the account you made on the website. And press the Create New Project button. Let's give it an informative name like Ethernet IO. And press Create Project. This has made a new project in this folder. And press this button to open the new folder in VS Code. With this folder open, we can see the starting files for a new project. Helpers.stanza holds definitions for helpful functions like options for sourcing resistors and capacitors, setting up the format for the bill of materials, and how we're going to export CAD. Main.stanza contains our design. slm.toml is for managing external libraries, and this stanza.proj file is for linking libraries that are local to your computer. So open main.stanza and run it by pressing this button at the top or by pressing Control-Enter. When you run this file, JITX creates a schematic, a bill of materials, and a board. The design information for the schematic and the board are in the Designs folder in the Design Info. So these files will hold the information for the schematic and for your board layout. It all stays local to your computer. We can export this design to CAD by running Export Design in the terminal. By default, Helpers configures it to run the KiCad exporter, and we can see in the Designs folder in KiCad, JITX has generated a KiCad project, board, and schematic, all fully linked. We can open this KiCad project and see that the board and the schematic have both been generated. There's our resistor and capacitor, and here is our generated schematic. All of this data stays local to your computer and is not uploaded to the cloud. Let's read main.stanza to figure out how that worked. We can press Control-B to close that sidebar. This file starts with defining a package, importing the common libraries. This line sets up the board shape to be a rounded rectangle of 30 by 18.5 millimeters. And this PCB module, my design, contains the circuits that will be turned into the design for the board. So it starts with example code, has example ports, which is the electrical interface to a circuit, example nets, and a couple of lines that add a resistor and a capacitor. And we can edit this code. Let's say selection copy line down, Control-Shift-D, and change this to a 22 kilo ohm resistor, save it, and run it with Control-Enter, and we'll see that another resistor will be added to our design. All right, so there's our other resistor. It's attached to the same pins, VDD and signal, as the 10K resistor. And you can see that it's been added both to the schematic and the board. And if I wanted to export CAD again, we would see that resistor showing up in the exported design. In the next video, I'll show you how to create circuits from components and nets in JITX, how to discover and use reusable libraries, and we'll build the USB debug interface to the microcontroller. After that, we'll show you how to customize the schematic to match your personal style, and then show the basic layout and auto-routing tools. Then we'll add the power section, really showing how parametric circuits can speed up your design process, and showing how to auto-route power circuits in JITX. After that, we'll add the Ethernet switch and the Ethernet jacks and demonstrate high-speed auto routing, including differential pairs and constraints for impedance topology loss and timing. Lastly, we'll add the microcontroller, digging into automated pin assignment and finishing up the communications core portion of the design. After that, things get more flexible, and we can build on what we've learned to add new networked sensors and actuators.